Well, hello, good morning, and good afternoon, everyone. Thank you so much for joining. We'll start in a minute or so. I'm just giving some time for people to start logging into the session, and then we'll get started right away. All right, I see quite a few people have joined the session already. I'm just going to start, and maybe we can go over some kind of housekeeping rules before we start the actual session. So, welcome again to our latest webinar. This is the business applications of large language models in publishing and media. So, we're going to talk a lot about all of that very, very quickly. As a little bit of house rules, we are not using the chat section today for question answering. So if you have any specific questions during the session, please drop them in the Q&A section. And we have Miriam here as well, so she can actually answer the questions right away. And in some cases, we'll also take them up to Mathis after the presentation is done. So we'll try and get to all the questions till the end of the session. At the end of this webinar, when you leave the webinar, you should also see like a survey, so it always helps us to understand better how the content was, how the topic was, and also what more we can do. And also if we need to get in touch with you. So please do take a minute to fill out that survey. It's a very short one. And without further ado, I would love to invite our host, the VP of Product at DeepSet, Mathis. Mathis, welcome. And yeah, the stage is all yours. Thank you so much for taking the time to do the session.
Yeah, thanks, Pari, for the introduction, and hi everyone. I'm glad you're all here, and I hope I can deliver an exciting presentation for you today, talking about business applications of large language models in publishing and media. Just a few words about myself. I'm Mathis, as Pari mentioned. I'm VP Product at DeepSet, responsible for our commercial product, DeepSet Cloud, that helps AI teams to build all sorts of applications with large language models quickly. And also for our open source framework, Haystack, that's more developer focused, and some more technical people here might know it. And today, I want to talk about basically an industry vertical that we've seen a lot in our daily work, where we have some customers, where we see some tractions. And it's sort of like one of my favorite industry verticals, publishing and media, because naturally I'm very interested in text data, because I like AI with language, meaning NLP, and who has a lot of text? Well, publishing and media. So I think it's sort of natural that there's a lot of interest, and there's certainly a lot of business value that you can uncover using large language models and similar techniques. And today I want to walk you through that. So what are we talking about today? I want to start with kind of a provocative question. What's your content worth? We're going to talk about that for a while. We're going to talk about generating content as sort of the elephant in the room. And then I want to talk about some maybe lesser known technical use cases like vector search, recommendation systems, and their business applications. So how you can actually leverage these in publishing and media, and what types of product products you might want to build with them. And then, of course, I'm also talking about actual large language models and what you can do with them. And in the end, we have the takeaways. And then, of course, as Pari mentioned, I try to answer any of the questions that you might have as comprehensively as possible. So let's get started. If we look at recent developments in large language models and how powerful they got, like I'm sure you've all played around with GPT-4 or GPT 3.5 and you were blown away by the capabilities. Maybe you found a few things that you didn't like as well, but overall, I'm definitely very impressed. And at the same time, there's like a lot of things where people are like, oh, we could improve that. Like it could get better. And I'm sure that some of you have been approached by companies like OpenAI or Microsoft or Google, and they were asking for your content basically to train their models on. And that is because essentially you hold the key to better large language models because we see two trends in research. We see as the first trend, if a model is trained on more data, it's a better model. And to illustrate that, a popular open source model, Llama 2, was trained on like 3 trillion tokens, which is probably something like a trillion words, which equates to something like 2 million entire Harry Potter series. So you can see like these models have been trained on a lot of data. And if you have more, your model is better. And you have a lot of content. So that's why they're coming to you. And then the second thing we see in research is actually if the data is better, if it's higher quality, the model is also better. We've seen that in a paper from Microsoft recently, for example, where they trained a smaller model on code generation. The name of the paper was Textbooks Are All You Need. And basically they trained on less data, but the data was really textbook quality. And that model was better than many of the larger competitors, basically. So these two things make models better, more data and better data. And you have both, like you have a lot of content, and then you also have highly curated, high quality content that has been written by humans, that has gone through review processes, peer review, editorial processes, and so on. So you've invested a lot of time and money and intelligence into that content. And that's why basically a lot of the big tech companies might be very interested in that content. But then I would really encourage you to think twice before you just sell that data, because essentially you're giving matters out of your hand. Like you're giving the products that you could build based on your content, based on your data, away to another company. And now they have the liberty to build whatever products they think work with that data. So let's talk about building your own products with large language models instead. And the first thing that probably comes to mind when you talk about media, let's take an online newspaper, for example, might be content generation. Like that's really the elephant in the room. If I could just generate content, I would have to have less writers, for example. I would reduce my costs, and that would be great. So that's like many think about content generation. I'm here to tell you, well, content generation can also be risky. We have this story published by CNN just a few days ago, actually, on November 2nd, where they highlighted that Microsoft's Bing news service is making a mess of the news because it's generated by AI and it produced a bunch of false claims and reports. And generally, as a respected newspaper, for example, that's not what you want. Like, imagine you're the New York Times, you're the Washington Post. You don't want to have some AI creating bullshit stories for you. So know that generating content is definitely risky. But the even bigger question is, does generating content actually add value to your business? And I found this quote in the New York Times from Madeline McIntosh, former chief executive of Penguin Random House. And she said, the challenge for publishers is not generating more content, it's solving the discovery problem. That's where the gold mine is. And what's that discovery problem? That's basically making the content that you do have more accessible to your readers, to your users, to your customers, making it more digestible. And generally, we're living in an age of information overload, and curation and discovery is something that people really pay for because they have a hard time finding the content that actually interests them. And on a even deeper level, if you think about it, let's say you just used ChatGPT, GPT-4 to generate your content and be faster. Well, the news is everyone else could do the same thing. And what happens if everyone else is using the same tools to generate content? Well, where's your differentiation? Like, everyone is just generating the same content. There's not going to be a lot of news value or information. It's basically very bland as well. So I don't see like where that would add a lot of value to your business. And where you actually add value is by uncovering unique insights that only you can uncover based on research that you did or based on data that you already have about your readers, about your customers. And that's something where you should focus on when using LLMs as well. Like, try to leverage LLMs to uncover more information, uncover new information, deliver something to your readers, to your users that they can't get anywhere else. And the same is true for connecting your users to your content. So if you have great content and you're delivering insights and you add a lot of value, you still have the problem of people actually need to read that and they need to be aware. And sometimes it's hard to cut through the noise. So leveraging large language models to connect your users to the existing content that you have in a way that is more useful and digestible is definitely something that you should explore as well. And I want to go to one technical application of how you can make your content more discoverable with large language models. And I want to start with that one because it's kind of the basis for everyone who wants to connect their data with a large language model. And that basis is vector search. And what vector search allows you to do is lets you build search systems that understand the semantics, the meaning of a question, instead of just looking for keywords. And just some of the business cases that we've been seeing here is you might want to speed up the research process for journalists in your organization by making your entire archive searchable. So imagine your journalists, they're working on articles every day. You might have millions of articles already in your archive. Whenever you're writing new content, that content that you already have is very interesting. It's a very, very valuable resource for research. And for many, this valuable research is pretty inaccessible. It's hard to use. And you can actually leverage vector search to make that more usable so that your journalists can produce higher quality research faster. Another use case might be in investigative journalism, where you have like a lot of unstructured data, maybe a data leak and of, I don't know, thousands of emails, or some data from a public institution that's public but not very accessible. And you can leverage vector search to make that data more searchable as well. And then if you look at companies who provide basically research portals, either for academia, like where you can access scientific journals, or also in B2B cases, like let's say you have a platform for legal professionals like Thomson Reuters, Westlaw, for example. These people generally will love your platform if they can find their content faster. It's going to be more engaging for them. They're going to use it more. They're going to prefer it over other platforms. So that's something that you might want to explore as well. And because many people illustrate vector search with this like coordinate system to try to explain how it works. I actually just want to show how it works, and I'm going to jump to our application for that in just a second. All right. So vector search, I've been talking about the semantics and how it's different from just keyword search. And what you have here is our platform that allows you to build these use cases. And I brought up our search demo UI, where I can compare different LLM applications essentially and see what the results would look like. And the data that I have here in this workspace is from Wikipedia. It's the 35,000 most popular Wikipedia articles. And if you look at that, you have like, I don't know, a lot of articles about any topic that you can imagine, basically the most popular ones. And I want to start with a keyword search here. So this is just your traditional keyword search. Many of you might have a system like that already for internal knowledge management on your website to search your content. And if I ask a question that requires a semantic understanding, like what do YouTube and PayPal have in common? The keyword search is bringing up, I'm going to make that a little bit bigger. So it's bringing up something. And if I look, I can see, yes, it's talking about YouTube. And is it talking about PayPal? Yes, it's also talking about PayPal, but that's not really the question that I asked. If I switch to vector search, which is this one here, and I ask the same question, I'm gonna get a different answer. And the answer that I get is YouTube is an American online video sharing platform, yada, 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 founded by 3 former PayPal employees. So that's vector search right there. The model has captured that this is asking about the relationship of YouTube and PayPal. It's not just, hey, we have the keyword YouTube and we have the keyword PayPal, and that's what I'm looking for. Understanding that these two terms have a relationship in my question, and that's how it brings up the result. You can see the same like here. You can see YouTube was founded by Chad Hurley, Steve Chen, and Jared Karim when they worked for PayPal. So you can see that connection. And vector search is going to make the search experience instantly better for your users, essentially. And then there are a lot of ways in which you can tweak it. I didn't tell the full story here. Like this is actually a hybrid search. There's also a ranker on top, but those are more like the technical details. What's important is that vector search can make your content more discoverable in a range of applications. And I'm going to switch back to the presentation after that short demo. And now I want to talk about the next technical use case and the applications that it might have. So the next one is semantic recommendation systems. And you've all heard about recommendation systems. Basically, if you have Spotify recommending music to you, that's a recommendation system. If you use Netflix, for example, you see, because you watched XYZ, we have these other TV shows that you might like. A semantic recommendation system can, given a piece of content, semantically determine which pieces of content might be similar. It can identify those pieces and recommend that to you. And here it becomes a bit more interesting in terms of use cases as well, because there are many things that might not be like very intuitive. Like you might think of that Netflix feature. One of our early customers, Manz, an Austrian legal publishing house, was the first one to bring AI to the German-speaking legal market by making a system that helps lawyers and paralegals to do case law research faster. Because what they did was they implemented that semantic recommendation systems where when a lawyer was looking at a certain case on their platform, it recommends similar cases, like that might have a similar verdict or a similar situation. And that would really accelerate their research because they need to know all that's relevant to their case and all legal rulings and decisions to make their case. And that takes a lot of time. A lawyer's time is very expensive. So that's a very strong and compelling business case. We had other customers, for example, who wanted to recommend books to their customers based on what they've read. So that's also something that you can build. And you can also build a sort of like semantic personalized index for your readers. Like imagine you're a newspaper, people come to your homepage, but it's not just your homepage, it's a homepage that's actually customized to their preferences and to their reading habits. And that's really powerful, especially if you combine it with the next thing, which is large language models. And large language models, really what they do is, and you all know it from ChatGPT, they can follow instructions, like you can tell them what to do, and then they generate text. And that text is usually pretty nice, and it's almost like talking to a human. And you can build a lot of useful things with that in media and publishing. One of the business cases that we saw is building virtual assistants, for example, for academics, but also legal professionals based on your data. So imagine you have a big database of legal data, court rulings, textbooks, and so on. And you can actually provide sort of like a conversational interface to legal professionals that helps them accelerate their research. You can even take it further, assist them in their editing of some contract clauses, for example. So that's something where large language models really shine and where they are really interesting. I also want to get back to that initial, almost like a rant against generating content. You can certainly increase the productivity of your writers. I write a lot, not not professionally, but like for my job. And sometimes I just have like writer's block, yet like I need to, I don't know, write up the new product strategy, but my mind is just blank and I'm blocked in my head. And whenever that happens, and I know that that happens to professional writers a lot, a large language model can really help you get going. Like use it to prototype an idea, like give it a few like bullet points. Hey, what can you make of that? Can you make a few suggestions? And then basically collaborate with the language model to speed up your writing process and avoid writer's block, for example. And we've seen for developers that their productivity increases between like, depends which study you want to trust, but between like 10 and 30 or 40%. We've seen that for knowledge workers as well. I think there was a big study by BCG, I'm not sure. They compared like people using LLMs versus not using LLMs. And the group using LLMs was more productive. I think had about a 20% productivity increase. So really, you can use these models directly to increase your productivity. But then on an even larger scale, imagine you're a publishing house and a big part of what your people do is reviewing manuscripts. And a lot of these manuscripts come in and they don't meet the basic quality standards. And you could leverage large language models to automate some of the process. I'm not saying like, hey, GPT, review this paper for me. But what you can do is, hey, GPT, give me a few pointers where these quality standards that we have and these prerequisites are met or not. And that could be a first quality gate that will free up a human reviewer to do the more thorough, in-depth review for the manuscripts where it's really worth to invest a lot of time. So that's another use case. And then you might also just want to make your content more digestible through using large language models as summarizers for your users. One application that is basically in everyone's head right now, and like a lot of people talk about, is that it is retrieval augmented generation. And for those of you who don't know what retrieval augmented generation is, basically you take your data, you take a retrieval method like vector search, for example, and then you have a user asking a question, and that question fetches data from your data store and then feeds that data into the large language model and then generates a nicely formatted human-like conversational answer. And it can synthesize from multiple sources. And that's also how you keep your model from hallucinating, because it's actually based on your data. You're not just asking GPT, hey, tell me something about something that you can't know because it's in my data and nowhere else. So that's generally a very useful technique. And it has a lot of benefits, like you have better content discovery. Maybe it's more engaging for the users in this interacting with your content and that conversational style. But what's maybe more of a hidden benefit is you can also use that as a tool to understand what your users are actually looking for. And to give you an example, we had a customer who launched a test run with a new RAG-based product, and they had a small group of test users who they invited to use the product, interact with it, and give feedback. And within a matter of days, they collected over 3,000 natural language queries, and these queries really tell them a lot about what their readers are actually interested in. And What types of questions do they ask? What preferences do they have, maybe? And I'm sure all of you have instrumented your content, like what people click on, what they read, how much time they spent on every page. But what you can't know is what's not on your homepage, for example. If you don't have any content about that on your homepage, you cannot track how users are reading it. But with a RAG system, they might just ask for it. And you can use that to think about, okay, what's the next content that we want to produce, maybe? Let's say you're a big book publisher in the technical space. I saw someone from O'Reilly, for example, signing up. And O'Reilly has like all of these developer-focused books and reports, and there's a lot of like optionality in what you can build. If they had a RAG system over all of their content for developers, they could track what developers are actually looking for, not just in a keyword search manner, but really like they are asking natural language questions. So they really ask for what they want, and you can analyze that. So that's really powerful. And I want to give you a quick demo of what RAG looks like as well. Let me just switch my screen again. Yes. All right. So I'm back in DeepSet Cloud, and I actually want to show you a little feature that we implemented quite recently. In this little chat window, I can ask questions to our documentation, and this is a RAG pipeline running here. So I can show you how that looks like. I ask a question, and then you can see it thinking, it's searching, it's generating text, and then it gets me a nice answer. Like I can ask for something, and it gets me the right answer right away without me having to dig through the documentation. And it also links to where it got that data from. So I ask about to get started, answers the question, and then links me to the getting started article in our documentation. Can also ask more specific questions like, okay, how do I add search filters? For example, we have filtering in our search. So it's explaining to me how I do that, and that's directly pertinent to my question. So that's a very useful and powerful thing to make your content more discoverable, searchable, engaging, and you get the added benefit of having access to what are people actually interested in. All right, so much for the demo here. And then let me get to the end of the presentation. Essentially, if you want to take one thing away from this, know that you are, as publishers and media, you're in a unique position. You have a lot of interesting, valuable content. You have insights that no one else has. And please don't just go ahead and sell that to some LLM provider. Try to build your own products with that. And then if you think about building products, don't just think about, hey, I want to generate my articles and fire all my writers. Like that's not a good idea. Instead, think about, okay, how can I use LLMs to make research more efficient internally, to improve processes like manuscript review, to make the content that I do have more discoverable and engaging for my readers by using techniques such as summarization or recommendation systems. And then also use LLMs to learn more about your customer and to drive future top line revenue. All right. I'm already done with the presentation, but now I'm very happy to take questions.
Thanks a lot, Mathis, for that talk. We do have like a couple of questions here already, and for everyone listening, if you have any other questions, please don't use the chat function, but please put it in like the Q&A section here as well. So Mathis, Anirban here is asking, well, it's also more like a suggestion or like a discussion point, to be honest. So he says like one major area where work could be done is understanding or sourcing or crowdsourcing news material. Do you have any ideas on how AI can help in that in general?
I'm not entirely sure if I understand the question correctly. News material meaning like crowdsourcing information, basically, or?
Yeah, I think it might mean, and Anirban, please correct me if I'm wrong, it might mean something like we can create like we can crowdsource a lot of news materials, and how do we research that entire material? So we have like a lot of reporters everywhere. How do you actually create like a new report as a reporter using all of this information that is being crowdsourced from everywhere? And thanks, Anirban. He says yes. That's what he means.
Yeah, so I think like generally LLMs help you to access data in a better and faster way, and also like more data. So if you think about, you have a lot of reports, for example, that you want to analyze, you can let the LLM summarize. You can look for certain things that you're interested in, and if you have like a lot of material, I don't know, on social media, you might be able to dig through that faster. I think that news organizations, they want to keep to their journalistic standards and review that. Like they can use that data, but it's still journalists, experts, basically making the decision what can go live, what can't. How do I need to edit that? How do I weigh these two things against each other? Do I have the full picture? But it makes the whole research process easier.
Understood. I hope that answers your question, Anirban. Now, Leonard here has an interesting question, I think, for us. He's saying, like, how does RAG work with DeepSet? And what LLM do you use for retrieval?
So RAG in DeepSet Cloud works pretty much how any RAG system would work, I think. You have a retrieval model, and then you have the large language model. What's special about DeepSet Cloud is that you're never going to be faster if you go anywhere else, because you have the data management set up. You have configurable pipelines where you can just switch out a model. So you can use any LLM, you can use OpenAI, you can use Anthropic, you can use Google's models, for example. So really just use any model you want. In the example that I showed, I used an open source retrieval model from the Hugging Face Hub, I think. And I think the name it's a sentence transformer model. Performs generally really good. But in essence, you can use any model you like on DeepSet Cloud.
Cool. So basically, we're model agnostic, right? So you can
Yes.
switch over any model you want. You can test different models. I think there's a lot of flexibility in there. There's another interesting question, like, what's your opinion on open source LLMs versus GPT-4? And can someone use them with DeepSet Cloud, basically?
Yeah, so I think like for open source LLMs, they're catching up. They're getting better and better. It depends a little bit on the language you want to use with the LLM, for example. We've seen that while GPT speaks many languages, some of the open source models are not as good in other languages than English. So that's a consideration. And then for RAG, I think what you should do is basically start out with OpenAI, figure out your business case, your use case, see if you can build something that your users like, and then you can start to optimize and try a different model because it's faster, for example, or because you want to keep the data on your side and not send it to OpenAI. So yeah, that's something where you might end up like using an open source model in the end, but figure the use case out first and the basic product, and then try to optimize the models, I would say.
Got it. Now, this is an interesting question again. This is about sudden events, it seems, so I'm not sure, but still, on a quick news report of like sudden events, do you see a scenario where how does an LLM help?
Yeah, we've seen like people from our company, even like I remember Tuana, our DevRel, when we had the earthquakes in Turkey, she helped setting up a system that used question answering models and techniques to assist like people having information needs, because of course when you're in a situation like that, information is very important, like where do I need to go for this, how can I get this, what's happening, and these systems can help both individuals but also like first responders, for example, teams supporting their can help. So that's an application. I think sudden news report events, of course, you could also install things where you monitor certain social media channels, for example, and the LLM detects like anomalies basically, and then you might be faster. So that might be an option, but I haven't worked on a use case like that.
Understood. Another question that we have here is I want to do retrieval augmented generation, but how do I tackle such a project, So as like a market leader, I think, as a business line leader. So what is the ideal team that you set up to manage such a project, and what are the things that we can do?
Mm-hmm. What we see is like we have many also, I don't know, executive level people coming to us, and they're like, we want to do something with AI. Please help us do something. And I think that's fine as a point of departure, but where you should get pretty quickly is, what are my most pressing business problems? And then looking into, can LLMs help me to solve any of these? So really find your business case, and then find why your users or customers would care about the thing that you're building as well. We've seen like most success with companies that came from a use case, and they have like, hey, our users have this problem and we think LLMs can solve that. And that's why we want to build a system. So you should start there, like identify your business and use case. And then in terms of the team you need, the beauty about the new wave of powerful large language models is that you don't need like to extensively fine tune models, train them on your own. So you need a lot less people. We are seeing an emergence of what we call an AI team. Can be data scientists, can be engineers with an interest in data science. They're a lot closer to product because they actually want to ship features instead of just building models. And in that team, you might have like one or two of these people, like we call them AI engineers now. You definitely need a product manager who has all of these, like, what's our business case, what's our use case, how can I gather feedback from our users? Like you have to have these 3 people, 2 to 3 people. And then what generally helps is having subject matter experts as well. Like if you're building a system for legal professionals, for example, you should have access to legal professionals who can test your system. And then you want to get a prototype up and running as quickly as possible. And that prototype needs to be live and usable by non-technical users, and it needs to run on your real data. And then you collect feedback, and from that feedback, you know instantly what you need to improve, basically. We've seen that so many times where we spend too much time maybe optimizing things beforehand, and then we tested it with users, and then they said, yeah, that's great. I love that. But this aspect, which we didn't think about at all, like, I don't know, a time aspect, for example, the search results aren't ordered by time. And we're like, oh, we didn't think that time would be important. It
Yeah.
wasn't a use case. Like for news, of course, time is important. But so these things, you figure them out when you test the system. So test, make changes, optimize, test again, and then integrate into your end application, get the whole data management synchronization running, and then deploy to production, monitor, and improve. That's what I can tell you roughly about how a RAG project might go.
Absolutely. Now, I have a technical question here, which is also interesting. So previously, working with anything that is machine learning, it required a lot of like data preparation, data labeling, etc. So, do I still need to do this if I'm using like LLMs?
Not as much. Like you don't need to label data. You don't need extensive pre-processing. You do need to know where your data is and how you can get it to the large language model. So that needs to be organized, and it usually takes a significant chunk of time in a project like this. And then you can optimize a lot on how you process the data. But I would do that later as well, like test it first and then optimize. And otherwise, I can't think of any like specific data preparation that you need to do.
Got it. And how do we deal with hallucinations in general? Like, especially with like news content, all of that becomes super important, right?
Yeah, so hallucinations are so they are when a model makes something up that isn't true or real. And this already gets a lot better if you use RAG, because you're feeding data to the model and you're saying, based on that data, please answer my question. So that already like solves most of the hallucinations. It can still happen sometimes. You can then try to optimize the prompt. And we also have another webinar about how to detect hallucinations with other models, and then you can take action based on that detection, essentially.
Got it. And I think a follow-up on that is, do you recommend training my own LLM? Is it really necessary now?
I think it's definitely not necessary to train your own LLM from scratch. I think very big organizations that you could see as being in publishing have tried that, Bloomberg. And they trained their own Bloomberg GPT from scratch. And I'm sure it has cost a lot of money, took a lot of time, a lot of talent and engineers, like a lot of infrastructure. Even getting access to all of the GPU infrastructure is going to be hard. But I would say I haven't tried the model, but from what I'm reading and hearing, I would venture the guess that this model isn't better than GPT-4. And I think you should leave training large language models from scratch to the experts and not try to do something that you have never done and then expect it to be better than the company that has done it for 10 or 15 years. Like you're in the business of media and publishing, not in the business of training large language models. Harry, you're still on mute.
But will like an open source model, so if we just pick a model like an open source LLM, do you think that would be we can build something that is as good as ChatGPT on it?
I think yes, for your use case, you can build something that is as good as ChatGPT. It depends on the use case. But for RAG system, yes, you could use an open source model and you could get similar results.
Got it. Oh, and a question just came in. Like, if you have a large corpus from Ofer, so if you have a large corpus of documents, for example, legal documents, how do you use RAG, and how do you feed all that content into the LLMs?
So let me maybe take a slightly longer turn to answer this question. I try to be fast. But basically, if give me a second to find my screen again. Yes. So basically, in this case, I have a large corpus of documents, which is Wikipedia articles. So you can see like I really have a lot of them. And the way I get them to the large language model is by what we call an indexing process. And if I go into a pipeline, these were the pipelines that that I've just shown, like asking questions about YouTube and PayPal. And if you look at this pipeline, we have like an indexing pipeline and a query pipeline. And this indexing pipeline is responsible for your data management. And this takes your data, does conversion steps, pre-processes the data, does the embedding step, so vectorizing the data, and then writes it to the vector database. And once you have that, you can use the query pipeline to query that data. So this one is accessing the same database, essentially, retrieving the relevant documents. You can see that this is a bit more complex. And then the next step would be a large language model here, which I didn't show in this pipeline, but that's essentially how you get the data to the large language model.
All right. Cool. And I think we can take like one more question, or if something comes up last minute. This a provocative one, so it's like if someone has an engineering background but is struggling to understand what an LLM actually is, so could you kind of describe what it is technically, like a 10,000-foot view of it,
Yeah, so a large language model is a neural network that has been trained on a lot of text. And what it learned from the text was basically fill in the blanks. So you have a text and some parts of the text were blanked out, and the model has to say what word goes there. So it has the kids are playing in the park and the man is sitting on the bank. And for bank, for example, you can see it can be something to sit on and it can be something where you get your money from. And because it has learned to fill in the blanks, it has learned the man sits on the bank versus I'm going to the bank to get my money, has learned like the neighborhood of bank is different depending on what the word means, basically. So it learns to tend to all other words in the context, which you call attention. And that way it can kind of understand language. And generative models can generate text based on text that you give it. So it's basically filling out the blanks again. You're giving it an instruction, and the model knows from all the training data that this might be an appropriate response given that instruction, very roughly. There are things that people, I think, can't explain fully, like you're talking about emergent behavior. I don't believe that they are conscious, but like it becomes very interesting at a certain scale, but that's basically how they work.
Awesome. Cool. So I don't think we have any more questions. In case someone has any questions, maybe just pop it in the Q&A section or the chat right away. And I'm gonna wait here for just a second. But apart from that, thank you so much, Mathis, for the presentation, and thank you so much for engaging in like this extended Q&A session as well. I'm sure like everybody got like a lot of wonderful insights from this. For everyone who's still in the session, if you want to have a chat with us, I'm leaving like the way you can contact us in the chat window. So please feel free to reach out. Oh, sorry, I think I made a mistake. Yeah, please feel free to reach out here. We'll be available to help you with your use cases, to help you understand what we can potentially build. And thank you again, Mathis. Yeah, I think that'll do us for today.
Thanks, Pari, and thanks everyone for listening. And just as the last thing, like who might be wondering, all of the images were generated using a large language model and a visual model.
That's super cool. Especially the one that's your background. I really like that one. Cool.
All right.
All right then. Take care, everyone. Have a lovely evening or a lovely rest of your day, and we'll see you in our next session. Take care.
Bye.
Bye.